Hi all, let's work on something a little bit more abstract and conceptual. So this time, instead of having equations to pick apart, we have a table and we're supposed to find some derivatives that involve the values in the table and involve a chain rule. The first one we're going to look at is h of x equals f of g of x. So just kind of as a warm-up, I've asked for h of 4. That means that I need to find f of g of 4. And we always start from the inside. So function g is in this column, and input 4 is in the bottom row. So g of 4 is 2. We are then supposed to take that input 2 and plug it into function f. So it was an output, but we're resetting. So here is function f, and here is input 2. F of 2 is going to be 1. Okay, so now with the derivative, we want to find h prime of 4, which first means we need to figure out what the formula for h prime is. Since h prime is a composite, f of g, that should be f prime of g of x times g prime of x. Okay, so if we want to plug 4 into that, h prime of 4 is f prime of g of 4 times g prime of 4. So we will have to work our way here from the inside to the outside again. That is not times, that's up. So we'll need f prime of g of 4. Okay, so g of 4, oh, we did that up above. G of 4 was 2, so that's going to become f prime of 2. G prime of 4, here's the G prime column. 4 is in the bottom row, so that's just going to be a 6. G prime of 4 is 6. And then one more step, f prime of 2, f prime is in the second column, and 2 is the top row. So we get 5 times 6, or 30. So this really makes you recognize that that chain rule applies to these abstract function notation problems as well, and think carefully about the process there. Okay, let's do another one. This time we're looking at f of x squared. So f is actually the inner function. The outer function is x squared. This time we're just going to go straight for finding derivatives. So let's figure out how we would find g prime of x. So we'd start with the shortcut for the outer function x squared. That would be 2 times the inside raised to the first power. So we don't have to write that, but that's what's really happening there. And then don't forget to chain. We need to chain out the derivative of the inner function. So if we want j prime of 2, we're going to get 2 times f of 2 times f prime of 2. Looking back at our table, f of 2, so here's f, and we're looking in that top row. So we have 2 times 1. F prime of 2 is 5, so times 5, so this is 10. All right, let's switch colors. Next, I have k of x equals f of x times pi to the g of x. So the first thing that jumps out at me is this is going to need a product rule. So when I go for k prime of x, I'm going to get pi to the g of x multiplied by the derivative of f, and then I'm going to take f of x multiplied by the derivative of pi to the g of x. That will need a chain rule. The derivative of pi to a power is pi to the power multiplied by the natural log of pi, but I haven't taken the derivative of the power yet, of the inner function, and that will be a g prime. Okay, so looking back up at our table, I'm going to be lazy this time and go ahead and just replace these all with 3's rather than rewriting such a long one. So all of those will become 3's. I need f of 3 and f prime of 3. F of 3 is 2. F prime of 3 is 0. So this is 0, and this is 2. And then I also need g of 3 and g prime of 3. G of 3 is -4, and g prime is 1/2. So this is going to become -4, and this is going to become 1/2, and this is also -4. Okay, so this first chunk, we have a pi to the -4, but that's times 0, so that's actually going to drop out completely. But then we have 2 times pi to the -4 times the natural log of pi times 1/2. So the 2 and the 1/2 will cancel. And then I'm just going to do a tiny bit of rewriting. I have the natural log of pi, and then the pi to the -4 becomes 1 over pi to the 4. So I'm just going to put that as a single fraction. ln of pi over pi to the 4. So that one's a little messy, but again, it's just a matter of recognizing that you need a product rule and a chain rule on that one, and then lots of finding information from the table. Last one, if I want the derivative of e to the x squared over f of x, that's going to need a quotient rule. So I'll want the bottom times the derivative of the top. The top does need a chain rule. The derivative of e to the x is e to the x, but we have to also take the derivative of that exponent if there's something other than x there, if there's another function there, and the derivative of x squared is 2x. And then we subtract the top, e to the x squared, times the derivative of the bottom, and the derivative of f is f prime. And then we need to divide by the bottom squared. Okay, and then if we're trying to plug 2 in to all of these, that means here as well, 2 squared times 2. Maybe I should have just rewritten this one, but hopefully you can catch all these. So everywhere you see an x, you replace it with the 2. And I get, okay, so I need f of 2 and f prime of 2, which I've had to find, but I don't remember. F of 2 is 1, f prime of 2 is 5. Okay, so this is going to become a 1, this is going to become a 5, and this is also going to become a 1. So I think I'm seeing e to the 4 times 4 times 1, but we don't need to write that, minus e to the 4 times 5. And then on the bottom, I just have 1 squared, which is 1. So it's really just 4e to the 4 minus 5e to the 4, which is -1e to the 4. That actually simplified quite a bit. Okay, so these can get a little tricky, but I think they're kind of good puzzle type problems where you really have to think carefully about where your shortcuts apply.